Okay, let's give you guys some more practice. So sketch the graph of this function here. Okay, so try to have a feel of what's going on here. What's happening here is that you've got this block here, x, and then you're timesing it with the natural log of x, and then you're timesing it with the natural log of x. So this is what's happening here. Try to understand what's going on here. You've got this thing times this thing here, bearing in mind that this graph here looks something like this. And then what happens when you square this graph? Well, anyway, try and sketch this the graph of this function. So press pause and have a go. Okay, so to do this here, try to understand what's going on here. So this bit here, this is your graph of, in a way, y equals x here. It goes through the origin, and what you've got here is the natural log of x times the natural log of x. So the natural log of x looks like this. So what happens when you get this and times by itself? Well, this bit here will be a very, very big number, but then when you times a negative big number, it will be a positive big number. So when you've got to use your imagination here. So at the moment you've got a graph of the natural log of x. So when you square it, you can probably guess it will look something like this. Something like this. So this is our guess for the natural log of x squared here, because if you think about it, if around here is minus 99, when you square it, it would be a positive, very big number. So it's going to be up here. This here is it's growing slow. It's growing slowly, but when you square it, it will still be bigger than this bit here. Okay, maybe something like this. It won't be as steep as this bit here, but it may be something like this. Well, when you square it, let's just guess it to be something like this. Okay, so here you've got this thing, and then you're timesing this thing over here. You see, you've got a zero here. You've got a zero here. So when x is 1, whatever. So when x is 1, you've got 1 times 0. You've got a 0 here. So that means the combination of the two here will be 0 at this point here. Okay. So, well, hang on. So you've got y equals x, which looks like this. And then when you square this bit here, it will look something like this. The point here is that you've got a 0 right here. This thing here is 0 at x equals 1. So you're going to have 0 times 1. So 0 times 1 is, the whole thing is 0. So you know your graph will do something like this. Well, you know your graph will be right here. It will go through this point here, 1, 0. Okay. The next thing to consider is, well, looking at this function here. Hang on. Looking at this function here, you've got this times this. If the thing is, if you put z, if you put 0 into the x, this whole thing here breaks down, because the natural log of x requires that x to be bigger than 0. Okay, so immediately we can discard the negative realm, and we can immediately discard that on x, that on 0. So we've got to consider. So looking at this here, the domain for this here is that the requirement is that x has to be greater than 0. Dead on 0, it breaks down. Anything negative, it breaks down. So now we've got to consider the negative. We can discard the negative realm, and we can discard the 0. So only consider the positive side here. Okay, because anything else, the function will break down. So now let's consider a point just to the right of x equals 0. So let's take a point just to the right. So now looking at this, so now we're dead on x equals 0. Dead on 0, it makes no sense. It will break down. So now let's select a number just to the right. Let's randomly choose this number here. So now our function here. Stick that very small number into here. You will have this. So now we are considering this number here, just to the right of x equals 0. So now you have a very small number. So when you put that 0.0003 into here, and then 0.003 into here, remember looking at this bit here. If you look at your natural log of x here, just to the right, it will be very, very big, but negatively big. Okay, negatively big, and so this bit here, when you put a very small number in here, it will be a very, very big, but negatively big. Don't forget, you've got to square it later. When you square it, it will be a very, very big, but positively big, because a minus big times a minus big, it will be a positive big. That's why you've got a positive big here. So this whole thing here will be a positive big here, and then you've got to times it with something very, very small. You see, you've got something very, very small times something very, very big. We can't really decide what happens. We can't really deduce what something very, very small times very, very big. You see, if you have something very, very big times something very, very big, then you can definitely conclude that it's going to be very, very big. But here you've got something very, very small times very, very big. You can't really deduce much. So let's just leave it as don't know for the time being. Okay, so let's try and look at it in terms of this now. If you put that value into here, then yeah, if you put this value here into our original function, it will give us this, which approximates to this. And still, we're still not sure what's really going on. It seems like it's small, but we can't really be sure yet. So instead of using this one here, instead of using this small number, let's take it to the extreme. Let's put a really, really small number into there. Okay, so instead of using maybe this is not small enough. So let's take it to the extreme. Let's put this number into here. Now, when you put this into here, so remember our original function was this: f of x equals 100. Equals what was it? Equals x natural log of x squared. Okay, so when you put this into here, that would be this times the natural log of this thing, and then this squared is this squared here. Okay, that would then take you to this. Okay, so this minus can go down here. That will take you to here. Okay, and then well, don't forget, when you're here, you've got this block times this block. So when you square it, you're getting this whole thing here multiplying by itself. So you've got, in a way, you've got this minus 100 times natural log of 10 times minus 100 times natural log of x. Merge these two to get 10 here. Merge these two together. That will then give you this. This times this will give you a positive 10,000 and so on. Okay, so it's blah 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 here. And then you will get to this stage here. Once you're here, you can conclude that is going to be a very, very small number. So you've got this thing times this thing. You've got a number with 100 zeros here, if you like. A very, very small number times this thing. Here, maybe you might have to think about this, but here, when you get to this stage, you can conclude that this is going to be a very, very small number. Okay. So what we know so far is this. We know that this is going to be a very, very small number. So you know our graph won't be doing something like this. Okay, because originally you've got something like this, and then you're timesing it with something that's, well, so originally our function was this: f of x equals x natural log of x. Well, originally our function was this here. Okay, but then if you break this down, this graph here looks like this. This graph here looks like this, a diagonal line here, and then this bit here looks something like this. Okay, here we can't really decide because this bit here is very, very small, and then you time something very, very big. So something very, very small times something very, very big. We couldn't decide. But the thing is, when you start to put this, when you start to put 10 to the power of minus 100 into here, you can see that overall it's going to be very, very small. Because earlier we couldn't decide, because earlier it was very, very small times very, very big. So we couldn't decide, but when you put this into here, you can conclude that it's going to be very, very small. So your graph will look something like this, as opposed to something that might come from very, very big. Because at the moment you've got this thing times something very, very big. Well, now you see, when you get this times this here, it won't be very, very big. It will be very, very small. So you know it's going to come from here somewhere. Okay, so far we know this, and we know it crosses here. I will continue in the next video. So, okay.